first I need to make a correction. SUREBRIDGE is not about steel bridges, it's about concrete, or basically preservation of concrete bridges, as was mentioned by John at the very beginning. So SUREBRIDGE stands for Sustainable Refurbishment of Existing Bridges, and the idea behind SUREBRIDGE, which started almost 2 years ago, was to actually preserve and bring back to life those concrete bridges which we are desperate actually for any further intervention in terms of strength and repair. So we're going to actually give an extended life to those bridges which are practically at the end of their service life, and we have no choice but tearing them down and then building new bridges instead. Well, again, thanks to John. He mentioned something about why we need basically to preserve or maintain our structures. No need to say that's the age profile of bridges. As was mentioned, we have many bridges in Europe which are in need for strength and repair, mainly because of the problems that we have with corrosion of reinforcement. We are facing ever-increasing demands on axle loads, and also repetition of basically axle loads on the bridges, causing a lot of problems with fatigue. And at the end of the day, a lack of resources for maintenance and upgrading would actually result in ugly pictures or ugly accidents like the one that we see down here. So what SUREBRIDGE is planning actually to do is just to come up with a sort of sustainable strength and repair method for bridges. Since I would say at the beginning of the 70s, major road owners and bridge owners, they have been striving after intervention methods, strength and repair methods, which could be done at the shortest possible time, because we don't like actually traffic interruption. And since the 70th, fiber reinforced polymers, for those of you who do not know what these materials are a new class of high performance construction material, which are around 10 to 15 times stronger than normal steel that we know. So what we do basically in FRP strengthening is that we have carbon fiber laminates, the black strips that you see out there, with a sort of structural epoxy. We just bond them to the structure, and you get your structure strengthened, and traffic can actually have its flow on top of the bridge. So there is no intervention, or basically there is no interference with the traffic flow. FRP materials have also, in the past 20 years, I would say, they have been widely used as a sort of decking systems. So we are thinking now, we have solutions today by replacing old concrete decks or even concrete decks in new constructions with FRP decks, since they are super, durable, no corrosion, no degradation in that sense. And what SUREBRIDGE is trying to do is just to combine this technology together. So we are thinking about a sort of intervention procedure by strengthening the bridge from the below with carbon fiber laminates, and also coming up with an FRP, complementary FRP deck from the top. And what we believe what we are going to actually get from this combination is a solution which actually preserves the ductility of the structure, unlike solely strengthening of the structure with carbon fiber laminates, which is considered to be one of its limitations. So in a nutshell, what we're planning to do, or basically the areas that we are actually providing innovation here, is the idea of combining these two solutions: complementary FRP deck, which is a tailor-made solution. We can literally make any sort of basically section that we are interested in with any arbitrary, I would say, mechanical properties, and of course strengthening from the below. For the purpose of strengthening from below, we have developed a solution so that we can use pre-stressed carbon fiber laminates. We know that we get a lot of advantages by using pre-stressing: better fatigue performance of the structure, controlling the crack width, better durability because of that, and also delaying the onset of yielding in the tensile reinforcement. The other area that we are actually working on is the connection between the FRP deck and the existing concrete deck. And for those of you who are active in construction area, you see that there is a new technique developing called stay-in-place formwork. And that would be basically FRP formwork, which stays in place and acts as a reinforcement for the rest of the life of the structure. And we are developing a sort of mortar-based kind of joining these two together, and this technology could be used in that area as well. So just to tell you a couple of examples, the great thing with this project is that the components that we are developing in this project could be actually used separately as well at individual, I would say, level. We had a bascule bridge in Sweden that we just refurbished with the FRP deck that I'm talking about. Later on we will explain more about that. That the project was completed last summer. With the system that I just mentioned regarding using pre-stressed CFRP laminates for strengthening of existing concrete bridges, we have performed a couple of projects so far. 2 bridges in Sweden and a couple of other structures. And also, as I just mentioned, this is just an illustration of the technology which we believe has a great future, staying in place formwork. We are right now working on a commercial project, 50,000 square meters of slab strengthening. Almost 20 kilometers of CFRP laminates are going to be used, and specifically we are going to use basically the pre-stressing method that we have developed. And just to give you an idea about the price difference that our solution has provided, the traditional steel framing solution actually raised a cost of 6.5 million euros, while this solution actually could do the job with 1.5, so 5 million euros saving for the structure owner. I think that was all. So I should say that we have 2 other partners, AIC from Italy, which is expert in concrete bridges and bridge engineering, and Fiber for Europe, which is a Dutch company expert in producing the FRP decks for us. And we will be, of course, more than happy if you would like to know more about our project. Thank you.
Dr. Haghani.